Space. Today we are going to learn types of operating systems. But before going to the types of operating systems, let us just revise what we have learned in the last OS class. In the last OS class, we have learned that the operating system is an interface between a user and a hardware. It acts as a bridge between the user and the hardware. Whenever user wants to execute a command, it uses the operating system to tell the hardware to execute the command of the user. We have discussed about the functions of operating systems, like operating system manages processes, it manages files, and it manages memory, it manages the errors in the operating system and the security. Along with the goals of operating systems is efficiency, reliability. Efficiency is the ability of executing a program in less amount of time. The less the operating system takes the time to execute a program, the operating system is considered as better. The next one is robustness. Robustness is the ability to handle errors occurred while executing a program. And the primary goal of an operating system depends upon the usage. For example, for laptops and personal computers we use in our daily life, convenience is the highest priority of the operating system. The system should be able to can be able easily understandable by the user. The user can understand the operating system and he should be able to use the functions of the operating system conveniently. Whereas in the case of rocket propulsions and the rocket engines, the operating system should be reliable. The system should give the output in the exact in the deadline, exact before the deadline. It should not delay its output. The output should be constant in every environment. So today we are going to discuss the further part of the operating system, that is types of operating systems. Types of operating systems, we have mainly six types of operating systems. The first one is batch OS. The second one is uniprogramming OS. The third one is multi-programming OS. And the fourth one is time share operating system. Fifth one is distributed. It's actually the sixth one. Fifth one is multi-processor operating system. Don't confuse in multi-programming and multi-processor operating system. Both are different. Processor. I'm going to give the detailed explanation of each type of operating system now. Just a minute. And the last one is real-time operating system. First one, batch OS. The batch OS is the first operating system which was introduced. In batch OS, the requirement of a user is written on a punch card using some punches, and these punch cards are collected and formed as jobs. Now these punch cards are introduced to a computer operator which scans the punch cards and interprets the operation and tells the hardware to execute that command. And the next programming operating system was introduced. In this operating system, the main memory, which in the last lecture we have discussed that a program will be executed only when it is reached, I mean, when it is transferred from secondary memory to the main memory, and the CPU executes the program line by line. Now, in the case of uniprogramming system, which is introduced before the multiprogramming in programming OS, only one program can be held by the main memory. At a time, the main memory can only held one program. Now, when the CPU starts executing the program, let's say if the program consists of a line which requires an input output operation. What is the meaning of input output operation? Input output operation means the line which takes the input from the user, like we write the scan functions in C programming. Here, in this case, when the program consists of an input output operation, the further program will be executed only when this input output operation is obtained from the user. But what if the user takes some time to give the input? The CPU will remain idle, which actually decreasing the efficiency of the operating system. So to overcome this problem, they introduced multi-programming OS. In this operating system, the main memory holds multiple programs at a time. Now, when a program executing by the CPU requires an input-output operation, then it will be removed out of the execution by the CPU, and the other program and the removed program will be sent to the input output operation. Until then, the other program will be executed by the CPU. Now, once the program takes the input output from the user, it will be again pushed into the ready queue, which which is further going to be executed by the CPU. If you don't understand about the multi-programming, you don't worry. Later, we are going to have a very detailed discussion of every operation about the multi-programming OS only. Time sharing operating system time sharing operating system is similar to the multi-programming operating system, but here they introduce the ability of preemption of a process. What is meant by preemption? Preemption is the ability to come out of the execution of the CPU after the some particular time. Like if a process being executing by the CPU takes so much of time, then the operating system will take the process, because it is taking so much of time, it can decrease the responsive time of other processes. So it maintains a particular time, and once the process takes more than the time, then it will automatically take that process and push the other process for the execution. Now this next one is multiprocessor. In this operating system, there are multiple processors working as a combined. Multiple processors, there are two types of multiprocessor operating systems. One is asymmetric multiprocessing. The second one is symmetric multiprocessing. In the asymmetric type of multiprocessing, the processors will be in asymmetric form. Means one processor will act as a master and all the other processors will act as slaves. Now, this master processor is responsible for the controlling of these slaves and assigning work to the slave processors. These slave processors will execute the given task given by the master, and once the task is performed by the slave processors, they return the process to the master processor. Here, in the case of asymmetric multiprocessing, The master processor does not work on the programs. It just manages the operating system and the its slave processors. The second one is symmetric. In this type of operating system, all the processors will be equally treated. All the processors will perform the program and all the processors are responsible for executing the task. There is no concept of master and slave. The next type of operating system is distributed OS. In this type of operating system, multiple computers from different locations will be connected through a network. Now, these all computers will combine and work on a single user interface. The distributed operating system is also divided into two types, asymmetric and symmetric, as same as multiprocessor. In the case of asymmetric distributed asymmetric, this distributing OS is also called as what we say distributed operating system. There is another name for this. Um, it is nothing but it starts. I'm not able to recall. I'll tell you when I get it into my mind. This distributed operating system is also divided into two types, asymmetric and symmetric. As same as multiprocessor distributed OS is in asymmetric distributed OS, one computer will act as master and it is only responsible for assigning works to the slave computers. And once the slave computer perform its task, it will return it to the master computer, and master computer manages the operating system. And in this symmetric distributed network, this I told you right, this distributed OS is also called as clustered network. Now, in the case of a symmetric clustered network, all the computers will act equally and all the computers will be responsible in performing the given task. The next one is real-time OS. Real-time OS is basically used in the rocket propulsions and in the airbags of car accident safety airbags, because the real-time OS is way more reliable than the other operating systems where the deadline is fixed, like the process should be executed before the deadline. In these all examines, the program should be executed before the deadline. It's very important. In such cases we use real-time operating systems. In real-time operating systems, it is divided into two types, hard and soft. The hard version is very accurate, even in point one seconds. And the soft system is also very accurate compared to the other operating systems. Seconds. These are basically used when the deadline is very strict. This is all about the type of operating systems. Now we are going to discuss about the multi-programming operating system. As I told you that we are going to our whole multi-programming OS. Our whole discussion will be on multi-programming the entire course of the operating system because it is very most important. Now, when the multi-programming operating system is introduced, when they found some problems in the case of uni programming operating system. As I told you that the program that is being executed by the CPU wants an input output operation, then it is waiting for the user to give the input. Until then the CPU is in the idle state, it is not working at all, which is actually decreasing the throughput of the CPU. Now what is throughput is the efficiency of a CPU to execute the instructions in 1 second. The first operating system which was invented as a uniprogramming is MS-DOS. Now, in the case of multi-programming operating system, main memory can hold multiple programs at a time. The advantage of this property is when a that is being executed by the CPU wants an input output operation, then it will be thrown into input output operation queue, and the next process which is in the ready queue will be executed by the CPU by properly using the CPU time. And this multi-programming is divided into two types. First one is primitive, the other one is non-primitive. In primitive, as I told you that primitive is also called as time share operating system. Write like this. This is time sharing operating system. In this, a process execute that is being executing by the CPU can be forcefully deallocated by the OS. And in the case of non-primitive, a process can only be deallocated the when the program is executed completely. No forceful deallocation. What is the use of primitiveness? Primitiveness is useful when a program takes very much time to execute. Then in that case, the processes which are in the ready queue will not be allocated for the CPU. They have to wait for a long time until the process that is being executed by the CPU. Remember one point, whatsoever the type of operating system, the CPU can execute only one process at a time. Can execute only one process at a time. Process at a time. And this is the difference between the preemptive operating system and non-preemptive operating system. That's all for today. I hope you like this video. If you like this video, please hit the like button and share to your friends. Subscribe to our channel for the in, interesting, like, for the upcoming videos, and get ready for your placement. Thank you for watching.